Evaluate the expressions, determine the exact value. The first expression is cosine of inverse sine of 1/2. We begin by evaluating the innermost function, which in this case is inverse sine of 1/2. The output or range of inverse sine is from negative pi over 2 to positive pi over 2 radians, including the endpoints, which means in standard position, the angle will be from 0 to pi over 2 radians, including pi over 2 radians, or from 0 to negative pi over 2 radians, including negative pi over 2 radians. On the unit circle, cosine theta is equal to x and sine theta is equal to y, and therefore to evaluate inverse sine of 1/2, we look for the point on the unit circle in this interval where the y-coordinate is equal to 1/2, which is this point here, and therefore the terminal side of the angle we are looking for is this ray. The initial side is along the positive x-axis, and therefore the angle in the interval that has a sine function value of 1/2 is 30 degrees, or in radians, pi over 6 radians, or 1/6 pi radians. This simplifies to cosine of 1/6 pi radians. And now to evaluate cosine of 1/6 pi radians, notice how this angle intersects the unit circle at this point, and therefore the cosine function value is equal to the x-coordinate of square root 3 divided by 2. This simplifies to square root 3 divided by 2. Next we have sine of inverse tangent of 1. The output of the inverse tangent function is from negative pi over 2 to positive pi over 2, not including the endpoints, which means in standard position, the angle will be from 0 to pi over 2 radians, not including pi over 2 radians, or from 0 to negative pi over 2 radians, not including negative pi over 2. On the unit circle, tangent theta is equal to y divided by x, which means to evaluate inverse tangent of 1, we look for the point on the unit circle in this interval where y divided by x is equal to 1. And this occurs when the x and y coordinates are equal, which is at this point here. Y divided by x is equal to 1, and therefore the terminal side of the angle in the interval that has a tangent function value of 1 has the terminal side here, initial side here, and therefore the angle in the interval is this angle here, 45 degrees, or in radians, pi over 4 radians, or 1/4 pi radians. This simplifies to sine of 1/4 pi radians. And we already have this angle sketched in standard position. The sine function value is equal to the y-coordinate of square root 2 divided by 2. Next we have tangent of inverse cosine of negative square root 3 divided by 2. The output or range of inverse cosine is from 0 to pi radians, including the endpoints, which means in standard position the angle is from 0 to pi radians in this interval here, including both endpoints. Now we find the point on the unit circle in this interval where the x-coordinate is equal to negative square root 3 divided by 2, which is this point here, and therefore the terminal side of the angle in the interval that has a cosine function value of negative square root 3 divided by 2 has its terminal side here, initial side here, and therefore the angle in the interval is 150 degrees, or in radians, 5/6 pi radians. And therefore this simplifies to tangent of 5/6 pi radians. And now we need to find the tangent function value of this angle. We already have the angle sketched in standard position, and therefore the tangent function value is equal to y divided by x. And y divided by x is equal to 1/2 divided by negative square root 3 over 2. To simplify, we can multiply the top and bottom by 2. Simplifying, 2 divided by 2 simplifies to 1 here as well as here. This gives us 1 over negative square root 3. If we want just negative 1, the square root 3, which is the exact value of tangent 5/6 pi radians. But let's also rationalize the denominator by multiplying the numerator and denominator by the square root of 3. This isn't required, but sometimes the value will be given in this form. This is equal to negative square root 3 all over square root 3 times square root 3 is positive 3. Let's give the value as negative square root 3 divided by 3. The last expression is cosine of inverse tangent of negative square root 3. And the output of inverse tangent is from negative pi over 2 to positive pi over 2 radians, not including the endpoints, which means the angle will be from 0 to pi over 2 radians, not including pi over 2, or from 0 to negative pi over 2 radians, again not including negative pi over 2. Now we need to find the point on the unit circle in this interval where y divided by x is equal to negative square root 3. Well, because the tangent function value is negative, we know it has to be in the fourth quadrant. Remember, when dividing fractions that have the same denominator, to find the quotient of the fractions, we can simply find the quotient of the numerators. Which means the point we are looking for is this point here, where notice how if we divide the numerators, y divided by x is a negative square root 3 divided by 1, which is negative square root 3. Let's just go ahead and show the work of y divided by x anyway. Y divided by x is equal to negative square root 3 over 2 divided by 1/2. We can multiply the top and bottom by 2. Simplifying before multiplying, 2 divided by 2 simplifies the 1 here as well as here, which does give us negative square root 3 over 1, or just negative square root 3. Which means the terminal side of the angle we are looking for is this ray. The initial side is this ray, but the angle is not 300 degrees or 5/3 pi radians, because that is not in the output or range of inverse tangent. We need to rotate clockwise to here, and therefore the angle is negative 60 degrees, or in radians, negative pi over 3 radians, or negative 1/3 pi radians. And therefore the expression simplifies to cosine of negative 1/3 pi radians, which is equal to the x-coordinate of this point of intersection, which is 1/2. I hope you found this helpful.